Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on February 9th, 2026, just about 2 weeks ago. It reveals that large reasoning models actually implicitly know when to stop thinking, and by unlocking this with a new method called SageRL, the authors managed to cut generated tokens by over 44%, while boosting accuracy by roughly 2%. The paper is titled, "Does Your Reasoning Model Implicitly Know When to Stop Thinking?" And as we'll see later, this offers a really promising path toward making advanced reasoning models much faster without sacrificing performance. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 outlines the proposed framework and its performance impact. The top panels reveal the core intuition. Standard sampling often generates bloated, incorrect chains, whereas Sage identifies concise, correct paths that are already within the model's capabilities. Moving to the middle schematic, we see how the method incorporates these efficient paths into reinforcement learning, essentially teaching the policy model to prefer those shorter, sharper reasoning patterns. Finally, the radar charts at the bottom quantify the success, showing that Sage-tuned models, represented by the solid lines, achieve higher accuracy across 6 benchmarks while using roughly half the tokens of the baselines. To make this concrete, Figure 2 illustrates the specific inefficiency the authors identified. In the reasoning trace, the section highlighted in yellow shows the model correctly solving the problem and reaching the answer, $800, using 500 tokens. However, the red section below reveals that it keeps generating for another 452 tokens, merely double-checking itself without adding value. Figure 3 then quantifies this redundancy across 3 models. The green bars indicate that in over half of the correct cases, the models continue generating text after already finding the solution, confirming that overthinking is a widespread issue. Table 1 compares the efficiency of these different sampling strategies. The top row lists the baseline random method, which reaches 84% accuracy but requires over 3,000 tokens. The middle section, labeled T-search with lowercase phi, shows that simply relying on the raw stop token is risky. Strict pruning drops accuracy to 79% because the model cuts off too early. However, the bottom section, using the proposed capital Phi score, is much more robust. It consistently achieves 92% accuracy with about 2,600 tokens, demonstrating that the new method effectively identifies the optimal time to stop. Table 2 shows the broader impact when we integrate this into training across 4 benchmarks. Look at the first block for the DeepSeek 1.5b model. Standard compression methods like AdaptThink in the 4th row do shorten the output significantly, but they hurt performance, dropping accuracy to roughly 80%. In contrast, Sage GSPO, shown at the bottom of that group, matches that efficiency with under 3,000 tokens, yet actually boosts accuracy to 85.2%. This confirms that the model is genuinely learning smarter, more direct reasoning paths. Well, Figure 9 tracks the training dynamics to show how these gains emerge. The first panel on the left plots accuracy, where the darker Sage lines clearly rise above the lighter baselines. Immediately to the right, the response length chart highlights the efficiency boost. While standard models plateau, the Sage variants drive token counts down much further. The final 2 plots reveal the internal shifts, showing that the model is confidently diverging from its old habits to lock in these sharper reasoning strategies. Finally, Figure 17 presents a case study comparing the baseline model on the left against the Sage-tuned version on the right. The standard model on the left finds the answer, but then drifts into the red highlighted zone, needlessly rederiving formulas and inflating the count to nearly 1,400 tokens. The Sage model on the right, however, stops immediately after solving it. This cuts the output to just 712 tokens, demonstrating exactly how the method eliminates redundant thinking. So wrapping up, the big takeaway is that models often know the answer long before they stop generating. By using SageRL to unlock this self-awareness, the authors cut token usage by 44%, while slightly boosting accuracy. This proves that efficiency doesn't always require smaller models, just smarter sampling. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.